So up to here we have already discussed, completed. What about this statement? Please let me know. पहला statement क्या है? As far as the observer by the track side is concerned, the clock on the train is running slow and length are contracted in the direction of motion. And the second is what? As far as the observer on the train is concerned, the clock by the track side is running slow and lengths are contracted in the direction of motion. What is the meaning of these two sentences? Let me know. Bataiye. I'm asking. We have 1 more minute. So I'm asking to Shashti Singh, K101.
Yes, ma'am.
Please, can you explain these two statements? What is the meaning of these two statements? Why we have written this symmetry? Why we are writing the frames of reference are equivalent?
Time dilation.
Please read these two sentences and let me know the physical significance of these two sentences.
Okay, ma'am.
Meanwhile, Samriddhi, please tell everyone to join fast.
Yes, ma'am, I'm telling them.
Srishti.
Yes, ma'am.
Please go through, read these two sentences and
Yes,
let me
ma'am.
know the physical significance of these two sentences.
Yes, ma'am, reading.
Otherwise, कौन बताएगा? Who will explain these two statements? Who will explain these two statements? Please, fast. Hello? Am I audible? Hello?
Ma'am, it explains time dilation to make velocity constant.
Yes. दोनों का मतलब क्या है? मतलब पहले रेड वाले का मतलब क्या है और ब्लू वाले का मतलब क्या है?
मैम रेड वाला स्टेटमेंट बोल रहे कि ऑन द ट्रैक साइड इज कंसर्न द क्लॉक ऑन द ट्रेन इज रनिंग स्लो. जो क्लॉक जो ट्रेन में रखा हुआ है वो स्लो चल रहा है एंड द लेंथ आर कॉन्ट्रैक्ट.
Let me know on the basis of rest frame of reference and moving frame of reference. So in terms of rest frame and moving frame of reference, please explain these two statements. Why both are symmetrical? Who will explain these two terms fast? जल्दी कौन बताएगा?
Ma'am, as the observer is on the track side, so for him the train is moving, but the clock inside the train it's running slow and lengths are contracted, and it is equivalent for the observer inside the train. For him, the train is not moving; it's at rest. But then also the clock, the lengths of clock are running slow and are contracted.
मतलब which frame of reference is moving with respect to other? So in the moving frame of reference, your clocks will take more slowly, so time delayed and length contracted in the direction of motion. It means what? And if you are in the rest frame of reference, means what? You can move with either you can move with the constant velocity or you are at rest, and your event is occurring in this frame of reference, then you can say that you are at rest. So whether you are in the train or you are outside the track side, from where you are observing any event. If you are inside the train and event is occurring inside the train, then you are in the rest frame of reference. If you are outside the train and you are observing event which is occurring outside the train, so you are in the rest frame of reference. So when you can say that you are in the rest frame of reference. So and whenever you are moving or your event is moving with respect to your observer. So means if your event is moving with respect to an observer, then you can say that you are in the moving frame of reference. Okay, maybe you are at the track side or you are inside the train. But if with respect to you, if with respect to your event is moving, then you can say that you are in the moving frame of reference. आप खड़े भी हैं, if you are standing still, but you are observing one event which is occurring inside the train, then you can say that you are in the moving frame of reference. So however the situation, always in the moving frame of reference, your time delayed and length contracted. Time takes more slowly in the moving frame of reference, and your length contracted in the direction of motion in the moving frame of reference. So you have to keep in mind when you can say that you are in the rest frame of reference. When you and your event is in the same frame of reference and both are not changing your position with respect to time or your space, then you can say that you are in the rest frame of reference. कब आप बोल सकते हैं कि आप रेस्ट फ्रेम ऑफ रेफरेंस में हैं? जब आप और जो इवेंट है दोनों ही एक दूसरे के रिस्पेक्ट में मूव नहीं कर रहे हैं. If and only if you and an event which this event you are measuring is not changing the position and with respect to time, then only you can say that you are in the rest frame of reference. Okay, train chal rahi hai, but you are in the train and your event is also in the train, then you can say that you are in the rest frame of reference. You are in the initial rest frame of reference. So clear? Okay, so what is the point?
Yes, ma'am.
This is a symmetry from where you are observing the event. And from where you are observing the event. So in the moving frame of reference, time delayed and the length contracted. So this is the beautiness of your theory of relativity. It is symmetrical because it's always all the laws of nature, and nature loves symmetry. So this theory of relativity also symmetrical, symmetry. Obeys all the laws of nature. So nature loves symmetry. So the theory of relativity does. Clear? Fine. So what? Up to here we have discussed about the Galilean transformation equation. These equations are what? These equations are the equation to transform the coordinate of any event in rest frame of reference with respect to the moving frame of reference. है ना? ये क्या है? The Galilean transformation equations are the equations given by Galilean which transform the coordinate of any event, coordinate x, y, z, the coordinate of any event in rest frame of reference to the moving frame of reference. The coordinate of this event in the another moving frame of reference, this is your as this frame of reference. But using what? Using the Newtonian mechanism. By using the Newtonian mechanism. But here, what you need after the theory of relativity, after the Einstein theory of relativity, special theory of relativity, what you have a two postulate of special theory of relativity. One is what? One is all the laws of nature remain same in all inertial frame of reference. Second is what? The speed of light in vacuum remains constant. But it is not on the basis of Newtonian mechanism. It is violating the Newtonian mechanism principle because according to Newton, C cannot equal to constant. C could be any value, could be infinite too. Okay, so what is this? This is the problem. This is the problem of Newtonian mechanism. And so what you need, you cannot apply. Now you cannot apply these transformation equation for all the motions, all the motions of object, which is under the special theory of relativity, which is obeying the Einstein special theory of relativity, because according to this special theory of relativity, your C equal to space by time equal to your C equal space by time equal to constant value. So if your space is changing, length contracted time, then there must be change in your time too. But it is not the case in the Galilean transformation equation. So what we need? We need a special set of linear transformation equation in which we have a what? And these transformation equation can preserve the consistency of speed of light between two inertial observer. What we need? We need a special set of linear transformation equation which can preserve the speed of light must be constant in vacuum between two inertial observers. And second is what? Account for the problem of simultaneity between these observers, because the relativity of simultaneity is the consequence of spatial theory of relativity. What is this statement? What is the significance of this statement? The problem of simultaneity means if two event which is simultaneous in rest frame of reference need not be simultaneous in moving frame of reference. So this is all. This is the problem of simultaneity. It is the problem in the theory of relativity. Why? Because in theory of relativity, two events in one frame of reference, if both the events are simultaneously, need not be simultaneous in another frame of reference which is moving with respect to this first frame of reference. Okay, so these two problems, and Galilean transformation equation was unable to transform the coordinate of an event from S to S dash by because we have a problem in the theory of special theory of relativity, because these transformation equation was unable to explain these two phenomena, because GT, Galilean transformation equation, was unable to fit into these two points, these two problems of spatial theory of relativity. First is what? In the theory of according to the spatial theory of relativity, the speed of light remains constant in vacuum between two inertial observers. Whatever your observer is moving, or your event is moving, or both are moving with each other, or away from each other, C remains constant. And second is what? Second problem is that if two events are simultaneous in one frame of reference, that is your rest frame of reference, need not be simultaneous in another frame of reference, that is your rest frame of reference. Am I audible? Hello? Hello?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. You are audible.
Audible, ma'am.
Okay, so these special sets of equations are your Lorentz transformation equations. So what we need another set of transformation equation which will follow both these 2 points of a special theory of relativity. So we have a Lorentz transformation equation. So these are what? If you have please 1 minute, wait for 1 minute. I'm using my writing pad. So if you have a coordinate of an event x, y, z and t in S frame of reference, that is your rest frame of reference, and suppose you have a coordinate x dash, y dash, z dash and t dash of this event in S frame of reference which is moving with respect to your first frame of reference with the constant velocity v. Okay, so these are your new set of transformation equation. We are calling it Lorentz transformation equation. My pen is visible to you all. Okay, so these are your what? Lorentz transformation equation. If you have a x, y, z and t are the coordinate of an event in S frame of reference, and suppose x dash, y dash and z dash and t dash are the coordinate of this event in S dash frame of reference. You know the relation between S and frame of reference. S is your rest frame of reference and S dash is the moving frame of reference, moving with respect to S along x direction with the constant velocity v. This velocity is v. So what are these? LT, Lorentz transformation equation. X is equal to x minus vt by square root 1 minus v square by c square. Y is equal to y, z is equal to z, and t is equal to t minus vx by c square divided by square root 1 minus v square by c square. So it is not now t dash equal to t as in case of your GT. It is not the case. And here Lorentz included one more factor. It is your 1 minus v square by c square. So your space coordinate also affected by this factor 1 by square root 1 minus v square by c square compared to your GT. And because your this SS is moving only in the positive x direction, So you are writing x is equal to x minus vt by square root 1 minus v square c square. If your s dash prime will move in the positive y direction, then you can write y minus vt by square root 1 minus v square by c square. Now the component of velocity will come into the picture. Here vx, here vy, and here vz. And this transformation equation remains same, and then this will become for y dash, and this will become for your z dash. So these are the LT, Lorentz transformation equation, and obeying all the postulates of your spatial theory of relativity, obeying all the and unable to explain all the problem of your spatial theory of relativity, and if we will use these transformation equation and will fit into any of the principle of your physics, any of the theory of your physics, it will fit properly, and it will give what? It will give result as the speed of the light remains constant, and two events, if you are observing two events and if both the events are simultaneous. Hello? Waiting, students are waiting. Hello? क्या बोल रहे थे? Very difficult to go from here to there. Presentation mode to. क्या problem था? Hello? Am I audible? Hello?
Yes, ma'am, you are audible.
किसको क्या इशू था? प्लीज बताइए. इस सिस्टम में कुछ प्रॉब्लम था क्या?
No, ma'am.
Okay. So this is your transformation equations for the to apply spatial theory of relativity for all the event that is occurring in the nature. Okay. So
ma'am.
Now, yes.
Ma'am, how the T dash equation came?
We will see. है ना? We are going to derive. ठीक है?
Okay, ma'am.
So here, so in terms of beta, in more symmetric form, if we want to write, so somewhere we have to take this constant beta equal to v by c, and thus this constant will become what? Gamma equal to 1 minus 1 upon square root 1 minus v square by c square. So you can write the gamma equal to 1 divided by square root 1 minus beta square. Okay, so it is in the more symmetric form. Your LT is in more symmetric form, where you have taken beta equal to v by c and gamma equal to 1 divided by square root 1 minus v square by c square. So we will see how this t equal to t dash equal to gamma t minus beta x by c come into the picture for the spatial theory of your spatial theory of relativity. Okay, so gamma is what? Gamma is 1 by square root 1 minus v square by c square. Gamma is what? Gamma is your 1 by square root 1 minus v square by c square. So you can write your equation like this too. So properties of gamma, you have to find it out. The theory of relativity will come into the picture. It is already, this plot is already given in your author-wiser book too. So when your speed v equal to 0.85 c, then you can see the theory of relativity come into the picture here like this. Then this factor gamma will dominate. When the speed will more than 0.8, and it is more prominent in when the speed is b equal to 0.85 c. Then this factor gamma factor will more prominent. You can see here, and this plot already given in your author-wiser book in the topic of theory of relativity. Clear to you all? So to derive these transformation equation as we did in case of your Galilean principle of relativity, as we have already derived in Galilean transformation equation, what you have to do, again you have to consider two frame of reference S and S dash, as we have already discussed in the GT. And at the origin, both the frame of reference, the origin will coincide. At t equal to 0, t equal to t dash equal to 0, your origin of both the frame of reference coincide, and x is parallel to x, y parallel to y dash, z parallel to z dash, and x dash, y dash, z dash, and t dash are the coordinates of this p event. This p event, you can let us consider this event is p. This event in the frame S dash, and x, y, z, t in frame S. है ना? These all things we have already discussed in the GT. Fine. So what is this? What is the event here? So event is what? A flash bulb goes off at the origin. The flash bulb, the light emitting from this flash bulb. What is the event? Event is a flash bulb will goes off and on. The light emitting from this flash bulb is the event, and you are observing this event. And initially at origin when t equal to t dash equal to 0, our flash bulb goes off, है ना? आपका flash bulb बंद है. This is the event, and this is the initial conditions. These are the initial conditions. At t equal to t dash equal to 0, the o equal to o dash, है ना? And both this is very compulsory condition. For both the inertial frame of reference, when we are going to derive the transformation equation, you have to keep in mind your x dash, axis x dash parallel to x, y parallel to y dash, z parallel to z dash. Okay, and event is the light coming from the flash bulb. So at the origin, everything is what? Initial condition, O equal to O dash, and flash bulb goes off. So now what you have to keep in mind, because you are adding one more thing, as in case of GT, you are not taking C equal to constant. So but here it is the transformation equation, and which is obeying all the postulates of a special theory of relativity. So you have to take second postulate into the this calculation. So what is the second postulate? The speed of light. The speed of light in vacuum for both the inertial frame of reference remains constant. For both the observer, it remains constant. Okay. If the speed of light remains constant, so what happened? The wavefront for the light for this event observed in both the frame of reference must be spherical. Because why? Because of this condition, C remains constant. है ना? यदि C constant नहीं है, तो you cannot consider the wavefront observed in both the frame of reference is spherical. It could be anything. It could be different in both the frame of reference. If and only if you can take this condition, then C equal to constant in both the frame of reference. Okay, got it? Am I audible? Hello?
Yes, ma'am.
Yes,
Okay,
ma'am.
okay.
Yes, ma'am.
Okay, so these are the situation
Yes,
for
ma'am.
your derivation. So what we have to do, because of the spherical wavefront and this C is satisfying this condition of a spherical wavefront, so we can write equation of a spherical wavefront in S frame of reference like this: x square plus y square plus z square equal to c square t square, and this equation is for your axis frame of reference, because in both the frame of reference you have a spherical wavefront light के लिए. Okay, and C equal to constant. If and only if C equal to constant, then you can write these equations. And in Galilean transformation equation, you cannot write these things. This value for this spherical wavefront, you cannot write these equations. These are valid only for when you are taking into account the C equal to constant. Clear to you all? So you have to keep in mind these equations are not invariant under GT. Under GT, if आप GT लेके चलेंगे, Galilean transformation equation लेके चलेंगे, तो ये condition satisfy नहीं होगा. These are constant when you are taking into account both the postulates of special theory of relativity. Clear to you all? Fine. So the note is given here. These are not invariant under Lorentz transformation. यदि Lorentz transformation, sorry, GT लेते, so this equation not invariant, will vary under GT. Okay, fine. Clear to you all? So what you have to take to derive your value of gamma, कैसे gamma आया, and how t equal to t dash come into the picture. How your t equal to gamma and t dash minus beta v by c कैसे आया आपका. Okay, so you are going to derive these, and you are taking into what? You are taking a spherical wavefront, taking the equation of a spherical wavefront in both the frame of reference as we have taken before. Okay, so let us consider what? Let us consider x dash equal to gamma x minus vt. है ना? पहले कंसिडर कर चलते हैं कि gamma फैक्टर ऐसा हो सकता है. है ना? These are what? X dash equal to x minus vt is the gt, is the transformation equation for x dash according to gt. But है ना, suppose let us consider that the scientists suppose that mathematically theoretically उन्होंने ये suppose करके चला कि maybe this factor in gt is not like this, it is multiplied by one factor gamma. It could be multiplied by this factor gamma. So they have taken all these means proposal like this and they write the formula for the same, है ना, for the transformation equation. So at x is equal to what? Gamma x minus vt. Let us consider that. उन्होंने उस time ये सोचा, है ना, कि let us suppose let us suppose that x is equal to gamma x minus vt and x equal to, so inverse should be true. ना, so inverse should be true. So x equal to gamma dash x dash plus vt dash. Clear to you all? Am I audible?
Yes.
Hello?
Yes, ma'am.
Okay. So
Yes.
if x
Ma'am?
is equal to gamma x minus vt, yeah.
Ma'am, what is gamma here?
Gamma is the one factor. है ना?
Ma'am, can you explain
They
it?
thought that scientists. I am explaining, beta. मैं explaining तो कर रही हूँ उसको. We are deriving this value of gamma in this way, है ना? Just suppose किया कि एक constant है and your transformation equation could be modified by this gamma factor, है ना? So we are what? हम क्या ले रहे हैं? हम different possibility लेके we are going to derive these equations. है ना? So let us consider gamma is the one factor, and if we are taking into account or both the postulates of special theory of relativity, तो पहला postulate तो same था, है ना? Your first postulate 60% तक it is valid for both the GT and LT, okay? And your theory of relativity and your special theory of relativity. Only second postulates come into picture after the special theory of relativity. So for to fulfill this C equal to constant, है ना? Scientists thought that time maybe this x dash equal to x minus vt multiplied by one common factor gamma, constant factor gamma, है ना? So we are going to derive this factor, okay, by applying some conditions. Okay. So and the inverse also true. So x equal to gamma dash x dash plus vt dash. So this is the inverse relation. Same inverse relation if you are going from S to S dash, S to S. Clear to you all? So this is your first equation. And by Einstein first postulate, the C equal to constant, your this factor should be equal in both the frame of reference to fulfill the condition of spherical wavefront of light. According to Einstein postulate, this gamma, if it is multiplying in the into your space coordinate, then there should be a relation of these gamma and gamma dash according to the first Einstein postulate. What is this postulate? All the laws of nature remains same in all inertial frame of reference. So it is due to some law. Okay, so according to the Einstein principle of relativity, so we can write gamma equal to gamma dash. But according to the first postulate, what is the first postulate? All the laws of physics remains constant in remains same in both the frame of reference. So gamma equal to gamma dash should be equal to gamma dash. Okay, if you are using this condition, gamma equal to gamma dash, putting this equation in here, both the equation 1, okay, and then the wavefront along x and x direction. You are taking this wavefront equal to what? X square equal to ct square. Along x direction की बात कर रहे हैं. If you are talking about only x direction, then you can write x square equal to ct square, x is equal to ct dash square, because c remains constant. Understood? So this is your second equation. Put the value of both the x and x dash in equation 1. You will get what? Ct dash equal to gamma ct minus vt and ct equal to gamma ct dash plus vt dash. Both the equation in your what? This is in t, in terms of time. Both the equations are in terms of time. This is your direct relation. This is your inverse relation. Fine. What you have to do? You have to find value of t dash from this equation. Now you have to find it out, the value of t dash from this equation, and please put this value of t dash in this equation. Or one more thing you can do it. You can find it out the value of t from this equation and put the value of this t in this equation. Vice versa, you can do both the things. Result will be the same. Result will be the same. Okay. So for what are you doing? Solving the first equation for t dash and substituting this value of t dash into your this inverse relation. Ct equal to gamma ct dash plus b t dash. Clear to you all? Hello?
Yes, ma'am.
Understood? Okay. So in this way, if you will solve, it is your what? It is in t dash. This term is in your t dash. So t dash to t dash cancel and you will get this value of gamma in this way. If you are applying all the condition of your special theory of relativity, then you can get what? This value of unknown factor gamma. So this gamma factor is what? Your gamma equal to 1 upon square root 1 minus v square by c square. Gamma factor is what? Gamma factor could be your, could be nahi, hoga, ye hai, gamma equal to 1 upon square root 1 minus v square by c square. So what is your x? X, I am not using my pen, I am using my finger. So x is equal, this factor gamma, so x minus b and this t divided by now square root 1 minus b square by c square. So this is the transformation equation from s dash to s to s dash for the x, because your this s frame of reference, s dash frame of reference moving with the constant velocity v with respect to x along the x direction, positive x direction. So it is your x minus vt by square root 1 minus v square by c square. Because you know the value of gamma now. So you can put in your first equation x is equal to x minus vt by square root 1 minus v square by c square. Our inverse is also true, x equal to x dash plus vt dash divided by square root 1 minus v square by c square, because gamma both the frame of reference is equal according to the Einstein special theory of relativity. Clear to you all? So this is the value of gamma. Now what you have to find it out? If you know the gamma, you know the value of x dash, y dash, z dash. Now what you need to know? The value of t dash. The value of t dash. So to know the value of t dash and you know the gamma value, so what you have to do? Abhi tak t dash ka kuch nahi malum aapko. So you have to find it out, t dash. So you have to recall both these equations. You have to recall both these equations. So this is your first equation. These are your first equation. So to simplify these equation for your t dash in terms of x, because you know the value of x now. So you have to solve what? You have to put this x dash value from here to here. You have to put this value of x dash from here to here and solve for t dash. Solve for t dash, you will get what? X upon gamma v 1 minus gamma square plus gamma t. So which may be written in terms of beta equal to v by c. आप beta के term में लिखिए, ना लिखिए ना, simplify करिए. If you will simplify this equation, if you will put the value of x and will put the not put the value of x, if you will put the value of your gamma from your previous PPT. Previous slide, then you can get what? T dash equal to t minus vx by c square divided by square root 1 minus v square by c square. So this is, ऐसे आया t equal to t dash equal to t minus vx by c square upon square root 1 minus v square by c square. So this is the way we derived. Lorentz derived the transformation equations of coordinate of any event for the one frame of reference to the another frame of reference in this way. Now, if we will use this c equal to constant, so c equal to constant आप लेके चले हैं, then only you can write t dash equal to t minus vx by c square divided by square root 1 minus beta square. आप यदि c constant नहीं रखते तो you cannot write this equation x equal to ct and x is equal to ct dash. So you are taking into account the c equal to constant and while following these two postulates of special theory of relativity and derive the transformation equation. So these are your Lorentz transformation equations. So these are direct equation and these are your inverse. inversality. Clear to you all? Directality and inverse also too. है ना? So symmetrical with respect to what, which frame of reference is moving. है ना? With respect to what which frame of reference is moving, you have to write down your Lorentz transformation equation. है ना? In the frame as frame of reference and as just frame of reference. And if it is moving in the positive direction, so you have to take the positive velocity. If you are writing in the if your frame of reference is moving in negative direction, so you have to take minus v, velocity equal to minus v. So it will become what? Positive v. It will become positive v. And here again I am telling you, you have to keep in mind, because you are taking the simplest example, your as is moving along x direction, then only you are writing this. It is not here your frame of reference not moving along y direction, z direction, then only you are writing y dash equal to y, z dash equal to z. If your axis frame of reference will move in the positive x direction, y direction and z direction with the constant velocity vx, vy, vz respectively, then your y dash will also you can write y dash similar fashion, in this fashion, in this manner. So y dash equal to y minus v yt square root 1 minus beta square, and z dash equal to z minus v zt square root 1 minus beta square. Clear to you all? Clear to you all?
Yes,
Understood?
ma'am.
Yes.
Okay, so velocity transformation equation, you have to go through whatever I have shared with you, this PPT, relativistic velocity. Now your velocity is not like this, whatever we have seen in the previous example, the truck and ball wala jo example liya tha, it is not like this. Your velocity will not add like this manner, whatever we have discussed according to the GT, according to the Galilean principle of relativity, according to the Galilean transformation equation, like we have already discussed the example of your truck and ball. Okay, so it is not the way. Now you have to see the relativistic velocity. Velocity will add according to this theory of relativity. Okay, so you have to go through this PDF, whatever I have shared with you. Okay, I think 1 week before I have already shared, na? Hello? Did you get this?
Yes, ma'am.
Okay.
Yes, ma'am.
So you have to find it out. In which frame of reference you are observing the event? In which frame of reference you are observing the event? So it is your as frame of reference, and other is your moving frame of reference. Clear? From where you are observing the event, the as frame of reference, है ना? And बस आपको एक बात याद रखना है कि event and observer, if event and observer is at rest, not moving with respect to each other, then this is the rest frame of reference. If your event and observer is moving with respect to each other, then this is the moving frame of reference. है ना? ये बात हमेशा मान में रखिए कि क्या मूव कर रहा है, which is moving. You are observer or event. If observer is moving or event is moving with respect to your observer, if observer is moving with respect to event, event is moving with respect to observer, both are your moving frame of reference. If both are not moving with respect to each other, then this is the rest frame of reference. तुम चाहे कितनी भी स्पीड से, है ना, if you are going in a train with this approximately 85% of the speed of light, then only if you are inside the train and you are observing this event which is occurring inside the train, you are in the race frame of reference. Clear to you all? Understood? So now these are the consequences of special theory of relativity. We can use this LT also to derive time dilation, जैसे बहुत सारी बुक में दिया हुआ है, and we will take this example also to understand your special theory of your time dilation. These are the consequences of special theory of relativity, time dilation and length contraction. Okay, so what is this time dilation? हम बहुत बार बोल चुके हैं, time delayed in the moving frame of reference. Time dilation मतलब हमेशा dilation का मतलब क्या है? Time dilation मतलब in moving frame of reference. Length contracted means in the moving frame of reference. जब भी हम time delay बोलेंगे, उसका मतलब क्या है? One can ask time delayed in what? moving frame of reference. Land contracted in what? Moving frame of reference. Okay, so time delayed and land contracted in the moving frame of reference. So what is the meaning of this? Time interval is the shortest in reference frame where a clock is at rest. Time interval is shortest. Shortest means जो आपका proper time होगा उस event के लिए, this is the shortest. इससे ज़्यादा नहीं हो सकता, इससे कम नहीं हो सकता. This is the shortest time interval in the rest frame of reference. When your event and your clock, when observer observing any event in which frame of reference, and you have one clock and you're observing the time duration, and time duration को time duration की बात कर रहे हैं. Time duration, time interval for this event to occur. Time interval है ये, है ना? So don't confuse with time coordinate and time interval. So it is time interval, और जो हमने देखा वो time coordinate था. At a particular time t dash, and this is what? Time duration, है ना? 5 hours, 6 hours, 8 hours, whatever the time interval it is. Did you get it? Understood?
Yes, ma'am.
Okay. So time interval, time duration, you can say that is the shortest in the rest frame of reference, and in the moving frame of reference, it appears slower to an observer. ना clock appears slower. Slower का मतलब धीरे धीरे चलेगी, मतलब time delayed. In this frame of reference, time delayed. है ना? It appears to delay. मतलब ऐसा दिखेगा आपको कि it is delaying, time delaying, because your moving clock ticks more slowly compared to the clock at the rest. So this is your time dilation. Time dilation का मतलब time interval delayed. 5 घंटे का 6 घंटे, है ना? Like this. Hours, मतलब कितने duration we are talking about. And in IT you are taking t dash equal to t minus v x by c square by square root 1 minus beta by 1 minus beta square. So it is what it is the coordinate of your any event at this time 5 p.m. है ना? Okay, and suppose time interval 5 p.m. to 10 p.m. है ना? So 5 p.m. to 10 p.m. this is the interval of time interval, and this 5 p.m. is your time coordinate of any event occurring at 5 p.m. समझ गए? Understood? Hello? Hello?
Yes,
Am I
ma'am.
audible?
Yes, ma'am.
Okay. So what you have to prove this, to derive the formula for time dilation, है ना? What you need to do, you need to again take the two frame of reference. One is moving, one is rest. है ना? जब भी हम theory of relativity देखेंगे, we need to discuss about two frame of reference, in which one frame of reference will move with the constant velocity v, and one is at rest, है ना? Related to the other. Okay. So both are the inertial frame of reference. You know that. है ना? So first of all, what? Let us consider that this is the example of one train compartment, है ना? And your event is what? This is your flash bulb. You can see that this is your flash bulb, and light ray is emitting from this flash bulb, and this light ray is approaching to the mirror which is placing at the roof of your train compartment. Okay. Okay. And one observer is here inside the train and observing this event, measuring the length. Measuring the length. So this observer has a length scale, and to measure the time, and to measure this time interval or time, this observer has what? Its own clock in the train. So this is one frame of reference. So what? Your event and you, the event and observer in the not moving with respect to each other. So it is your what? Rest frame of reference, stationary frame of reference. Rest frame of reference is S. However, this train is moving with the constant velocity v with respect to the track side, with respect to track side. जबकि ट्रेन क्या कर रही है? मूव कर रही है constant velocity v से along x direction. You can say that along x direction. किसी भी direction में move कर सकती है. So it is here. It is in the x direction. Clear to you all? So this is your what? S frame of reference. And one frame of reference is what? If suppose the event is occurring inside the train, same event is occurring inside the train, and one observer which is outside the track side, which is outside, now at the track side, observing this event, and this observer has its own length to measure this, and on clock to measure the time interval for this event to occur. Understood? Clear? So this is your what? Moving frame of reference. Why? Because your event is moving with respect to this observer. Our observer is moving with respect to this. Both are moving with respect to each other. Clear? Understood?
Yes, ma'am.
Okay. So in both the frame of reference, the C remains constant. In both the frame of reference, C remains constant. So the time taken, time duration, this is what? Time taken for this event to occur. Event is what? Light ray coming from this flash bulb to approaching the mirror. After reflection, it will come to the source again. So this is the time taken for this event to occur. So time taken by this light ray approaching to this mirror and coming to the observer. So what is the time? The distance, let us consider this distance from this source to this mirror is d. So it is what it is your 2d. It is your 2d. एक d जाने में plus दूसरा d आने में. So it is your 2d. Okay, 2d by c, because you know that the time equal to distance by speed. So in this, from this relation, you can write T naught. Why you are writing T naught? Because this event is occurring in the rest frame of reference. Okay, so you are taking T naught. This is the proper time of the event. This is the proper time. We are calling this as the proper time. So proper time is what? Proper time is the time interval for any event to occur in the rest frame of reference. तो रेस्ट फ्रेम ऑफ रेफरेंस में जो भी टाइम इंटरवल ऑब्जर्व किया जाएगा वो कहलाएगा आपका प्रॉपर टाइम. सो द प्रॉपर टाइम इज व्हाट? यू कैन डिफाइन द प्रॉपर टाइम एज द टाइम मेजर्ड, time taken for an event to occur in the rest frame of reference. We can call it proper time. Okay, and this is the shortest time. This is the shortest time interval. Okay, so again for the second observer, what you have to do? For this moving frame of reference, observer is here, your observer is outside and your event is inside. Okay, so when this observer will observe first event, the ray is coming from the source approaching to the mirror. In this duration, after this time, your train will move with the displacement Vt. Your train will move with the displacement Vt. Okay, and your position of mirror will change. A constant नहीं रहेगा. Now the position of this mirror will change, and now after reflection, and also the position of your initial final point where you are observing the event, so it will also change after time t. Because your train is moving with the constant velocity v with respect to this observer. So it is your moving frame of reference. Now it is not the time taken is not now 2d. It is what? 2s. 1s, s plus s. So it is 2s. It is what? It is your s plus. Am I audible? Hello?
Yes, ma'am, you are audible.
Okay.
Yes, ma'am.
It is what? It is now your 2s. And 2s what? 2s is, you can see that 2s is large compared to your 2d. And this 2s will come here, distance, space, numerator. So it is what here? So the time taken by this event to occur is what? So 2s by c. If 2s is large compared to your 2d, then this will take what? Longer time. This will take longer time. This event to occur will take longer time. This event will appear longer, take in a longer time interval compared to the first for this observer. Clear to all? So what you need to do? You need to find it out by which factor it is delayed. By which factor it is delayed. So you are going to derive this factor. Okay. So let us consider this L. From here to here and this L, okay, and in this time t, your displacement of the train is Vt, so you have to take the you have to apply Pythagoras theorem in this triangle, red color triangle, जो में है ना. Okay, so in this triangle, suppose this is your A and this is your B and this is your C. So right angle triangle ABC, you have to apply the Pythagoras theorem. So it is your about L square equal to D square plus VT by 2 square. Understood? Clear? And you know that, but distance traveled by light is 2L in the second case. So then you can write the time taken for the second frame of reference T equal to 2L by C, distance by C. So put the value of T. No, sorry. You have to find it out the value of L from here and put this value of L from here to in this first equation. So it will come Ct by 2 whole square equal to D square plus Bt by 2 ka whole square. Okay, now you have to find it out what? The value of this D. So this value of D will come, you can find it out from the first relation. T naught equal to 2D by C. So Ct naught by 2 equal to D. So you can write D square equal to Ct naught by 2 ka whole square in this equation. And simplify this equation, you will get what? You will get, final term you will get T equal to T naught by square root 1 minus V square by C square. And you have to keep in mind gamma is greater than 1. This factor 1 by square root 1 minus V square by C square is greater than 1. So time delayed in the moving frame of reference. Time delayed means time duration. Why I am writing this del? Because this is the time interval. This is the time duration. It is not the coordinate. Time coordinate nahi hai ye. This is your time interval. So I am writing it here del t. है ना? T भी लिख सकते हैं, but confuse मत होइए. T coordinate it cannot be coordinate. It is your duration interval. So the proper time always less than the time taken by observer, which is time observed by observer in the moving frame of reference. Understood?
Yes,
Clear?
ma'am.
Okay. So this is your time dilation. This is the time delayed for the. So what is the example of your time dilation? Yes. Yes.
Ma'am, why this time dilation takes place? I mean, what the cause of it?
Because of the speed of light. When any object will travel with the speed of light, then this time delayed because of two main postulates of a special theory of relativity. पहला तो आपको पता है. Second is C remains constant. To keep the C remains constant, the time delayed if one object approaches to the speed of light, if the motion of any object will approach to the speed of light. Okay, then this is the assumption. Assumption nahi bol sakte. It appears as it is. It appears as it is longer. It appears as it is longer. Time delayed in the moving frame of reference. If this is not the case in your daily life. It is not the case in your daily life. It is for the when the speed approach to the speed of light. More than 85% of the speed of light. V equal to means approach to the V equal to 0.85 C. उसके बाद ही you can see that time delayed for the moving frame of reference. So first example you can take of mu meson. आपको क्या लेना पड़ेगा? To understand this time dilation, you have to take an object which will move with the speed of light, approximately speed of the light. So mu meson. So mu meson is the particle, nuclear particle. When highly energetic particle will hit the target, so from the nucleus you will get the pi meson. Okay, so these muon mesons are the highly energetic particle. The speed of these particles are what? How much? 0.99 C. Approximately speed of the light. It's 99% of the speed of light. So scientists observed this phenomena. To take the example of mu meson, because the mu meson is the particle, you can consider the object, and this object is moving with the speed of light 0.99 C, 0.99 C, V equal to 0.99 C. Okay, so if you will take, the experimentally verified, this time dilation is experimentally verified to verify the detection of pi meson. For the two different locations. One is in the experimental station, है ना, जहां पर the source and the detector is in very close to each other. What is the source? Source is when the highly energetic particle will hit the target, the pi meson will emit from the source, emit from the target with the speed 0.99 c. So what you have to, these experimental this already done by scientists to verify this time dilation. Okay, so what they did, they kept one detector near the source, near the target, and one detector very away from the target. Let us consider 30 meters away from the target. Okay, so what they found in both the detector, one is very near to the target and one is very away from the target. It is not, target means source of pi meson, emission source of pi meson. Am I audible to you all? Hello.
Yes, ma'am.
Audible, ma'am.
Okay.
Yes, ma'am.
So what happened in both the distance? They observed the flux of pi meson, है ना? So if very near detector, they got 100% of flux for the pi meson, है ना? And what pi meson? Pi meson is the half lifetime of pi meson is 1.8 × 10⁻⁸ second. The half lifetime of pi meson is, means इतने half lifetime बाद वो dies away. So if time will not delay, because they are traveling with the speed of light 0.99 c, then क्या होना चाहिए? Second detector पर, that is very away from the source, आपको flux मिलना चाहिए?
No, ma'am.
हाँ, मिलना चाहिए कि नहीं मिलना चाहिए? हेलो, यदि टाइम डिले नहीं
Ma'am,
हो
your
रहा है
screen
तो
is not visible.
why my screen is not visible? It is, I am not showing the screen, just it is time dilation PPT, just I am discussing this example to you. हेलो.
Yes, ma'am.
Yes, ma'am.
हाँ, अब बताइए कि सेकंड स्क्रीन पे क्या होगा? आपको फ्लक्स मिलेगा कि नहीं मिलेगा? यदि टाइम डिले नहीं होगा तो नहीं मिलना चाहिए,
नहीं मिलेगा मैम.
only 2% नहीं मिलेगा. And this is the observation, this is the experimental verification. That scientist got the flux, very away from your detector. It means what? Time delayed. The half lifetime of these pi meson delayed from 1.8 to 10⁻⁸ second to 10 into 10⁻⁸ second, है ना? इतनी ज्यादा फैक्टर से delayed this time. So these pi meson is approaching, है ना, towards your second detector that is away from your source. So this is the experimental verified example of your time dilation. Did you get it? Fine. Shall we discuss the length contraction? Hello?
Yes, ma'am.
Yes,
Fast
ma'am.
we have to go. Very fast we have to go. Okay, length contraction, you know that. And length contraction, you know that if the airplane is flying in the sky, then it appears very small. So this is the example of length contraction. है ना? Length contract in the direction of motion. X direction में ही यदि move कर रहा है with the speed of light, then the length contracted in the X direction only, not in the other direction. Okay, so this is the again we have taken the example of your same example we have taken for the time dilation, but you are rotating this, you are rotating your compartment को आपने rotate कर दिया है, and this observer is observing what? This length traveled by light, path length traveled by the light, path length traveled by the light from this source to mirror and mirror to here again, है ना, एक पोजीशन पर जहां पे डिसाइड कर लिया है ऑब्जर्वर. Okay, so this is your as frame of reference, this is again your moving frame of reference. So according to the knowledge of your time equal to distance by speed, again the knowledge of your time equal to distance by speed, you can write 2L0 by C. L0 is the proper length of any event, any object in the rest frame of reference. What is the definition of proper length? Proper length is the length of the object in the your rest frame of reference. Am I audible? सुनाई दे रहा है भाई?
Yes, ma'am.
Ma'am.
I am going very fast because we have to complete it. Okay, so this is the relation T naught equal to 2 L naught. So from here you can get the value of L naught. Okay, and now we are going to derive the relation between L naught and L. L is here. No, L is here. So we are going to derive the relation between L and L naught as we have already derived similar manner. Okay, so for the moving frame of reference, because of the speed of your train with respect to this observer, your train will after time t your train will move with the displacement vt. It displaces this amount of vt. Displaces this amount. Okay, this train. Okay, so for this one, time taken for light to travel from source to mirror. यहाँ source से mirror पर जाने के लिए let us consider time t1. Your light is taking t1 time to travel from this source to this mirror is t1. So the distance traveled d1 equal to L plus vt1 equal to ct1. So you can write L for this L, t1 equal to L upon this relation, t1 equal to L upon c minus v. Similarly, the time taken by light to travel from mirror to source. From mirror to source, it is coming your L upon c plus v. It is coming your L upon c plus v. So total time taken by this light ray from source to mirror to source, t equal to t1 plus t2. So you will solve this, you will get what? 2L by c and this factor gamma square. If you will put this value of gamma from this previous relation t equal to gamma t naught, so and all these relations you will find it out. You can write what? T equal to gamma t naught. If you will write like this, you will get what? 2L by c, gamma equal to gamma 2L naught by c, because you know the value of your t naught, 2L naught by c, from your previous slide. So you can write L equal to L naught by gamma, or L naught equal to gamma L. You know that your gamma is greater than 1. So L naught is contracted. The L naught value is smaller compared to L. So you can say that length contracted in the direction of motion. Okay, and you know the example of length contraction. यदि आप airplane में हैं, तो your earth, your track side, your airport, will look very small. If you are on the airport, then if your airplane is flying in the sky with very high speed, then it appears very small. So this is the example of your length contraction. Clear? This is the variation of mass with velocity. According to the Newtonian mechanism, mass of any object remains constant whenever, whatever the motion, whatever the velocity of your object. But according to the Einstein special theory of relativity, the mass of any object, derivation part you have to go through this, otherwise you will discuss after your MCQ 1. Because derivation not coming into very easy derivation. Please go through this. So final result will be the m equal to m naught by square root 1 minus v square by c square. It means what? The body which is in the motion has the larger mass compared to the rest mass of the body. It means what? When any object will move with the speed of light, its mass will vary with the speed. Like this, in this manner, m naught by square root 1 minus v square by c square. M naught is the rest mass of the object. M naught क्या होगा? Proper mass of the object. जो actual mass है object का वो रहेगा m naught. And if it is in motion and the speed approaches to the speed of light, then mass appears larger compared to the rest mass. To the factor 1 by square root 1 minus v square by c square. To the factor 1 upon 1 minus v square by c square. Clear to you all? Hello? Hello?
Yes, ma'am.
Okay.
Yes,
So what is the example?
Yes, ma'am.
What is the example of your this mass will vary with the speed. So if you will speedboat, if you will take the example of a speedboat, when the speed is very small, then it will it drag very small amount of water. but the speed is very high, it drags more water. So it means what? ऐसा लगता है, ऐसा समझ आता है कि इसका मास बढ़ गया है ना? Now this speedy motorboat has a larger mass compared to its proper mass. So this is the example of your variation of mass with the velocity relativistic mass. Let you all, I have already shared the numerical problem with you, so you have to go through this for your length contraction, your time dilation, and your variation of mass with velocity relativistic mass. And please go through the slide, PPT, PDF I have shared with you for the addition of velocity, addition of relativistic velocity. Understood? Fine. So
Yes,
we
ma'am.
have completed the course for your MCQ1. All the best for your